Hello guys, so today I'm gonna explain the chapter 9 motion. So chapter 8, sorry, the motion chapter. So let's start. In everyday life we see some object at rest and others in motion. Bird fly, swim, fish swim, bird flows through veins and arteries, and cars move, atom, molecule, planet, star, galaxies, all in motion. So first line says that in everyday life we see each and other thing in motion. Suppose a car is moving. Motion actually means movement. Motion means movement. Something movement has happened. So think of motion around you happening now. Suppose the car is moving or the fan is moving. Everything is moving in motion. It is in motion. So that's example is given. The bird flies, the fish swims, the blood inside our body through veins and arteries flows, the cars move, and in depth level also atoms, molecule, planet, stars and galaxies are all in motion. We often perceive an object to be in motion when its position changes with time. Yeah, so when do we say an object that it is in motion? When we see its position changes with respect to the time. Suppose in the first second it was here, and after 20 seconds it is here. So we say that it is in motion, it is moving slowly. So however, there are situations where the motion is inferred through indirect evidences. For example, we infer the motion of air by observing the movement of dust and movement of leaves and movement of trees. What causes the phenomena of sunrise, sunset and changing of season? It is due to motion of earth. It is true. If it is true, why don't we directly perceive the motion of earth? So we say that the air motion we say that the motion of air is by seeing the movement of the dust particles or the leaves. So we do not directly say that air is moving. We see these, observe these things and then say. So it is inferred indirectly, that's it is saying. And in the case of sunrise and sunset also, we say that the earth is moving, and so these phenomena are happening. Then it is given, an object may appear to be moving for one person and stationary for some other. For the passenger in a moving bus, the roadside tree appeared to be moving backward. A person standing on the roadside perceived the bus along with the passengers as moving. However, a passenger inside the bus sees his fellow passengers to be trust. What do this observation indicate? So here what is this saying? When suppose you are standing here and the bus is moving. So according to you, the bus is moving. And according to the people inside the bus, they are in rest because they are only sitting in one place, they are not moving. But according to you, you are not seeing a particular person but the whole bus. So you observe that the bus is moving, but inside the people inside the bus, they say that they are in rest. So in this case, what to be said? Which observation is correct? Both the observation is correct. Also you have seen sometimes in the bus when you sit, it seems that the trees is also moving as you pass by, as the bus pass by, but it is stationary. So these are some instances. Then comes, most motions are complex. Yeah, we have seen that in this it is a bit complex, the motions. So some objects may move in a straight line, others take a circular path, some rotate, and a few others may vibrate. So motions are of very types. Some may move in a straight line, some may move like fan in a circular motion, some may vibrate like wave, and etc. These there may be situation involving a combination of these. So also in some of the cases, the object is in motion of straight line also, and also in circular path. that is combination of this. In this chapter, we shall first learn to describe the motion of object along a straight line. We shall also learn to express such motion through simple equation and graphs. Later, we shall discuss ways of describing circular motion. So, in this chapter, basically, we learn the motion in a straight line and its equation, related equations, graphs, and also a bit circular motion. So, let's see. It is just the introduction. So, discuss whether the walls of your classroom are at rest or in motion. So many of the students will say it is at rest because a wall is not moving, it is at rest. But according to some, it will be moving because inside the wall, the atoms, in the depth level, the atoms are moving always. So in this case, it becomes complex. But normally it is we can say it is in rest. Then, have you ever experienced that the train in which you are sitting appears to move while it is at rest? Discuss and share experience. So this is, you will also learn the laws of motion and all. So this all you learn what is given. We sometimes are endangered by the motion of object around us, especially if the motion is erratic and under control, uncontrolled, as observed in a flooded river, a hurricane, or a tsunami. The motion is erratic, means it is uncontrollable. Like when tsunami comes, no one can stop that motion. That's the hurricane motion, the revolving that. So in that case, it becomes dangerous for us. On the other hand, controlled motion can be service to human beings, such as generation of hydropower, electric power. Do you feel the necessity to study erratic motion of some objects and learn to control them? So also the motion which can be controlled, like which can be stopped, not like hurricane, motion of the tsunami, the controllable motion, it can be a boon to us. This motion will be can be used for generation of power. So okay, then comes the main part, describing motion. We describe the location of an object by specifying a reference point. Let us understand this by an example. Let us assume that a school in a village is 2 kilometers north of the railway station. We have specified the position of the school with respect to the railway station. In this example, the railway station is the reference point. So what is he saying here? That when we talk about something in motion, we take a reference point. Suppose here, what is this said? Assume that a school in a village is 2 kilometers north of the railway station. Here we are saying that school is here and the railway station is here. So the position of the school is said with reference to the railway station. So it is 2 kilometers away from the railway station, the school. So it is called the reference point. So we could also have chosen other reference points according to our convention. Yeah, we could also use some other. Suppose from Rina's house, the school is 2 kilometers away. So that, therefore, to describe position of an object, we need to specify the reference point called the origin. So make it underline. So to specify the position of an object, we take a reference point so that we could specify that position of the object. So then comes motion along a straight line. So before that, some terms which you should learn, that is scalar quantity. What is scalar and vector quantity? So scalar quantity are those physical quantity, which requires only magnitude and not the direction. Suppose distance is there. When you say 2 kilometers of distance, you only say 2 kilometer distance, not the direction. When distance will be with direction, it will be called something else. but only distance, if you say, it will mean that only 2 kilometer distance has been traveled. So, and vector quantity means where both magnitude and direction will be needed. So you will not understand this, but later in the chapter you will understand its example and in the depth. So let's start this. The simplest type of motion is the motion along a straight line. We shall first learn to describe by an example. Consider the motion of an object moving along a straight line path. The object starts its journey from, so the simplest type of motion is the motion in a straight line. A car is moving straight. It's so simple. It's only moving in straight line, not in a zigzag way or something else. So now consider the motion of an object. We are considering the motion of an object along a straight line. This is the motion. This is moving with the time in a straight line. From the object starts its journey from point O. From here it was at rest, and from here it started motion. Yes, suppose the car was here, it has given the engine and it started from this point O, which is treated as its reference point. So this will be the reference point, that is the origin, which you learned that we need to specify the reference point called the origin. So this will be the O, origin, reference point. Let A, B, C represent the position of object at different instances. Let A, B and C. Suppose the car traveled at A in 60 seconds, in B 35 seconds and C 25 seconds. So A, B, C represent the position of object at different instants. At first the object moves through C and B and then reaches A. So it first reaches C in 25 seconds, then after 10 minutes it reaches B, and total it will be 35 seconds, and then from here it will go to A, and it will be his final destination. So then it moves, the object moves through C and B and reaches A, then it moves back along the same path and reaches C through B. Then from here it is going back. Suppose here is the home, here is the school. You are again going school to home, going through B and C and then home. So the total path length covered by the object is OA plus OC, that is 60 km plus 35 km equal to 95 km. So it is said that you have first traveled to A, to your school, that is total of 60 km. Total path length covered. Total here we are saying not only this, we have also come to this. Suppose B is a shop where you want to buy something after the school. So first we have went there and then to B. So it will be called the total length. So it will be calculated as such, OA and then AC. So 60 plus 35. It will be 5, 10, 15, 20, 25, 30, 35. We would not stop at B, we would stop at C. I have made mistake, sorry. We first went to school A and then we returned to C where there is a shop. So the C is from here, how many distance? It is taken by 5, 5. So we will take 5, 10, 15, 20, 25, 30, 35. So here, so it is taken 60 plus 35 equal to 95 kilometers. So if you will be told to take to calculate the total length, you will always add the given things. This is the distance covered by the object. To describe distance, we need to specify only the numerical value and not the direction. That was I was saying. We only need to specify the distance, not in the direction in which it is went. So it is a scalar quantity. So there is a certain quantities which are described by specifying only their numerical value. This numerical value of a physical quantity is its magnitude. Magnitude means numerical value. Suppose kilometer, 5 kilometer, 10 kilometer. From this example, can you find out the distance of the final position C of the object from the initial point O? This distance will give you the numerical value of the displacement of the object. So now we learn what is displacement. So displacement is what? The shortest distance measured from the initial to the final position of an object is called displacement. You will underline this and then we'll learn. So here, what is displacement? First we travel from O to A and then came A to C. So which is left out? OC, and that will be the shortest path, and this will be called the displacement. So we'll study this part, and then the uniform motion, non-uniform motion, measuring the rate of motion, speed with direction, the vector quantity, and then some numerical value, change in velocity, what will be the velocity, what is called, then graph, then laws of motion, uniform circular motion, and it will be finished and you will study this and that. So meet you in the next class. Study this all the lines in depth, try to understand, and also try to understand the total length and the shortest path, that is the displacement and distance. Okay.